Welcome. Now it's on to the next step. So we have looked at how to get our arm to move. We've looked at how we know which angles we want it, as far as roughly the minus 90, plus 90, how that all works. But now we want to know specifically how we start addressing how we get to a very specific location on our smart servo arm. So let's go here and let's walk through the different values that we're going to have to compute. So this is our arm. The first value we're going to look at is how do we compute where this base servo has to turn to so that we can grasp the object. So it's certainly going to be between plus 90 and minus 90, but how do we calculate that? Well, it's pretty straightforward. At any given point, we're going to end up with an X location and a Y location. Now, we're going to start at 160. That's the middle of the road here. But and we're going to go, we're going to restrict our arm to go somewhere between minus 40 and plus 40 from 160, just because that's going to somewhat limit it. We're not going to go all the way over to this edge, but we're going to stay somewhere in this middle. If we're directly in the middle, we're also going to limit it. The length of our arm is going to limit it to 80. So we're going to go somewhere between 40 80. Now these coordinates are just pretty arbitrary, actually. They're just points that I've assigned on a grid. So again, we're going to start at 160. We're going to go plus or minus 40 that way. We're going to go from 40 to 80 this way. So our object is always going to be somewhere in this area. That's going to keep us from calculating things that are perhaps going to give us errors on our servos. So that's pretty straightforward. I'll show you the code in a minute, but this is simple. Actually, let's look at the code now. This is actually pretty simple trigonometry. So if I get from the OpenCV subscriber a message or something published to the topic that's going to look like pause colon x colon y, as far as actually positions, I'm going to have to turn that into angles for each of my values. And to do that, let's look at the very first one. So the first one is I'm going to get an X and a Y. This is my middle point. This is my arm length-ish. I'm going to go ahead and set my X value and to be in the middle of that. And then I'm just going to use arctangent to come up with the value of the angle given a known Y and an X. And this is going to come back in radians. And then I'm going to come out of that and turn that into degrees. And then based on where my value is, if I take that angle and subtract 90, that's going to give me the right angle to put it in those locations. So let's look at just that first one. By the way, I just printed out the value here. And notice down here, the very first Dynamixel ID, this is my turn on my base. And it's going to be set to that my angle, and it's going to go there at 50, a speed of 50. I could make it a little higher. I'm just keeping everything slow so I don't stress my arm. And so that's how I set the angle. So it's basically an arctangent of y and x comes up with my angle. I account for the fact that it's minus 90 to plus 90, and sure enough, that's going to set that angle for me. So that's my very first angle. That's pretty straightforward. Now let's keep going. Let's go back to this. Now what I need to know is what the angle is going to be for these two different servos. And that's going to depend on how far out my object is. So if I know the distance on this length of the arm, and I know the distance or the length of my arm, I can use the arc cosine to come up with the angle here. And the same is true with this angle over here, although this is a little trickier because sometimes I might want to actually move this a little further or up or back to actually reach down and grasp the object. So there's a little bit of flexibility there based on where I am. Now let's go to the code and take a look at that. So I'm going to go to the code and notice that I'm going to now set my arm angle. This is my, again, the distance. I'm using that arc cosine, my distance and my arm length. That's going to come up with an angle. I am then going to go ahead and for the first arm angle, that's the lower of the two servos, I'm going to do a minus 90 to give me the correct arm angle based on where my arm angle is in the minus 90, 0, plus 90. And I'm going to go ahead and set that first arm angle again using speed of 50. Now the second arm angle, I'm going to do something quite similar, but this one is this, I've added this little 1.5, which gives me a little bit more of a swing on that angle to actually kind of come at the object in the right way. And this was arrived at a little bit empirically, but then I can set up that second arm angle. So those are the arm angles I'm going to use to set up and find my object. So now how do I evaluate this? How do I actually run it in the system? Well, I can do that by going ahead and opening up two terminal windows. I'm going to show you a picture of that here. So I'm going to come up with two terminal windows. The one terminal window, this one down here, I'm going to run ROS2 run my ID robot, and then I'm going to run the servo subscriber node. So that's the only nodes it's going to be running. And then in this terminal, I can send it over the topic a message. So I'm going to publish to the topic servo a standard string message. And in this case, I'm sending it pos colon 160 colon 80. And what that will do is that will cause all the calculations to go. And down here, you can see the calculations for all the angles so that I can position my arm. And here is a picture of that positioning. So the base moves, the first servo moves, the second servo moves, and again, based on those numbers that I'm passing it, I can evaluate, did it go to the right value based on those different locations. So for example, I can go back here, I can look and I can set up and start seeing, okay, where if I ask it 120 and 80, does it go to here? Does it, so I can set up, and the bottom units are the units of the servo controller. The top units, by the way, are going to come to us from, these are units that the webcam is going to calculate, but it's going to, the OpenCV subscriber is going to take these and turn them into servo position coordinates before it sends it over. We're not going to do that in the servo world. So now we're able to, again, run our arm and manually say, go to this location, manually go to this location. It will calculate the right angles for the three servos and go to that location.